Wow. The defining moment in solar spectroscopy happened in 1869, so just 10 years after the invention of the spectroscope. There was a total solar eclipse that two independent scientists, Young and Harkness, both used spectroscopes to observe. And during that total solar eclipse, both Young and Harkness independently observed a type of light that had never been observed on the Earth before. This spectral line appeared in the green part of the spectrum, and scientists had no idea what generated this line. They had never observed anything at this particular wavelength before, and therefore they made the presumption that this was an element that only existed in the sun's corona. It wasn't until more than 60 years later, in the 1930s, that a Swedish scientist proposed that this wasn't in fact a brand new element, but that it was a very, very highly ionized form of iron. In fact, he proposed that of iron's 26 electrons, that 13 of them had been removed in order to produce emission at this particular wavelength. Now, initially, this seemed like a very far-fetched idea. In order to remove 13 electrons from iron, that requires a huge amount of energy. In order to produce iron with 13 of its electrons missing, we call that iron 14 in astronomy, that requires temperatures of more than 1 million degrees Kelvin. Now, one of the main reasons that scientists were skeptical about this is that the sun's surface is only 5,000 to 6,000 degrees Kelvin. And now we're talking about the upper layers of the atmosphere being at more than 1 million degrees Kelvin. So where's all of that energy coming from? And you know, that's something that we still don't have a solid answer for. Although scientists continue to investigate and produce theories, there is no widely accepted answer to why the sun's corona is more than 1 million degrees temperature. This is the solar coronal heating problem, and it's one of the great unanswered questions in solar physics.